Welcome to Chem 1A at Shasta College. This is the remaining material from the class on Wednesday, September 2nd, the material we didn't get to during that time. And we'll pick up with question 6, which we started but didn't quite get through. And first of all, part D, what is the volume of this 0.7176 molar copper sulfate solution that's needed to provide 6.415 grams of copper sulfate? And we did actually do this at the very end of class, but I'm going to do it again two different ways just to kind of show you some possibilities. First of all, we want 6.415 grams of copper sulfate to be provided, so that is our amount, specific amount, not a conversion factor, that we will start with. So we have that number of grams of copper sulfate. And then what we know is that there are 159.61 grams of copper sulfate per 1 mole of copper sulfate. And that converts from grams of copper sulfate into moles of copper sulfate. And then, since it's a 0.7176 molar solution, we have 0.7176 moles of the solute copper sulfate per 1 liter of the copper sulfate solution. And that converts moles of copper sulfate into liters of solution. And that works out to be 0.05600 liters, which is about 56 milliliters, of course. And this is of the copper sulfate solution that's needed to provide 6.415 grams of copper sulfate. Now, it's worth noting that there's another way to do this based upon the information that was given in the problem. And sometimes one way is easier, sometimes another. But again, we want 6.415 grams of copper sulfate. But then we can also note that the problem gave us mass of copper sulfate per volume of solution. And so we could, in this particular case, say our conversion factor is there's 28.637 grams of copper sulfate in 0.2500 liters of the copper sulfate solution. And our conversion factor then cancels out the grams of copper sulfate, gives us liters of copper sulfate solution, and once again we get 0.05600 liters of the copper sulfate solution. And if we have a mass and a volume, then we can do a mass to volume conversion directly. But in many cases, what we will know is the molarity of the solution, and we're going to want to do it the way that we did the first time. Next, we are to find the mass volume percentage of this solution, the copper sulfate solution we've been dealing with. And note that a mass volume percentage is going to be a mass, typically in grams of our solute, which in this case is copper sulfate, divided by a volume, typically in milliliters, of the solution. In this case, it's a copper sulfate plus water makes the solution. And then the percentage, we do times 100% to get a percent. And so in this case, what this is going to be is our mass of solute is 28.637 grams of copper sulfate. Our volume of solution is 0.2500 liters, which is 250.0 milliliters of this copper sulfate solution. And then times 100 gives us percent. And when we work this out, it gives 11.45%. And this would be our mass to volume percent of this solution. And of course, there are mass to mass percents and volume to volume percents, other different kinds of percents depending upon the circumstances. But here, mass volume percent of this solution is 11.45%. Last part on this problem is we have a solution that we've talked about before. It's 0.7176 molar, and we would like to use this solution to make 1 liter of a 0.200 molar copper sulfate solution. Notice that this is more dilute than our starting 0.7176 molar solution. And as seen previously, there's a couple different ways to go about this. First of all, one way we could do this is to say we have 1 liter of a 0.2 molar solution that we would like. So we have 1 liter as our starting amount of solution. We want a 0.2000 mole per liter solution. And using that conversion factor, pretty simple math in this case, we have 0.2000 moles of, specifically this is of copper sulfate, this is 0.200 moles of copper sulfate per liter of solution that we need in our final solution. And then what we can say is, if we have 0.2000 moles of copper sulfate that we need, and we're going to get this from a solution that is 0.7176 molar, then there are 0.7176 moles of copper sulfate per 1 liter of that solution. And that allows us to convert from moles of copper sulfate into liters of this solution. Turns out to be 0.2787 liters. And notice that this is of the 0.7176 molar solution that we started with. So that's the calculation. We need 0.2787 liters of the more concentrated 0.7187 molar solution. Now, how do we actually make this? Well, what we're going to do is we are going to start with our 0.2787 liters of the more concentrated 0.7176 molar copper sulfate solution, and we're going to take that and combine it with enough water, and typically we use distilled water, pure water, purified water, and we would like to make a total of 1 liter of our new, more dilute solution. So note, we don't measure out how much distilled water we add. We measure carefully the amount of the concentrated solution, and then we just add water to that until we make the total volume of solution that we would like. Now note, there's another way to do this as well. We have this equation that we've seen before, M1 V1 equals M2 V2. This is a dilution equation. It works for dilutions. It doesn't work in general. And it tells us that the molarity times the volume of one of our solutions, let's say the solution that we would like to make, which is our 1 liter of 0.2 molar solution, is equal to the molarity times the volume of the other solution which is, let's say, the more concentrated 0.7176 molar solution, which we know the molarity of, but we don't know the volume of. So if this is the case, if we call this solution 1 and this solution 2, then we know the molarity and the volume of solution 1. We know the molarity of solution 2. We don't know the volume of solution 2. And so doing the math, the volume of solution 2 is the molarity times the volume of solution 1 over the molarity of solution 2. And the molarity of solution 1 is 0.2000 molar. The volume of solution 1 is 1 liter. The molarity of solution 2 is 0.7176 molar. And that ends up equaling the volume of solution 2 that we would like. Molarity cancels, do the math, and what we get is 0.2787 liters. And this is, of course, of the more concentrated 0.7176 molar solution. Same values we got before, and same conclusion as before. We take 0.2787 liters of the more concentrated solution, add enough water to make 1 liter of the dilute solution. So either way we do this, M1V1 equals M2V2, or just rationalizing and calculating on the basis of moles, we get the same answer. So notice that, just a reminder, the more concentrated solution can make a more dilute solution by adding water and diluting it. And in general, M1V1 equals M2V2 is the dilution relationship. Not generally applicable, works for dilutions. And question 7. Last question on this screencast, last bit of information or problem we didn't get to during class. We have a sample of Shasta College water. It has a hardness of 63 ppm calcium carbonate by mass. What is the molarity in this water? Show your work. Now, thing to note is that ppm stands for parts per million. And this is a concentration unit we often use for very dilute solutions. There's also ppm for parts per billion. And how we work this through, kind of like with previous problems, we need to know what the units mean. So mass percent, we need to know what that means. Molarity, we need to know what it means. Parts per million, we need to know what it means. But when you think about it, this is pretty clear. It's parts per million. So if we have a hardness of 63 ppm calcium carbonate, then what we have is 63, and this is by mass, 63 grams of calcium carbonate, so 63 parts, out of 1 million parts, and we're doing it by mass, so grams, of the Shasta College water. So that's what it is. 63 grams of calcium carbonate, our solute, in 1 million grams of water, our solution. Now, notice this is pretty straightforward in a sense if we want to get molarity, because molarity is moles of our solute calcium carbonate per liter of our solution, which is the Shasta College water. So what we need is we need to convert the grams of calcium carbonate into moles and the grams of Shasta College water into liters, do the ratio, and we're done. So let's do this calculation. 63 grams of calcium carbonate. It turns out that there are 100.09 grams of calcium carbonate per 1 mole of calcium carbonate. And so that conversion gives us basically 0.63 moles of calcium carbonate. So 63 divided by 100. And 1 million grams of Shasta College water, well, what we know is that this is pretty dilute solution. This is basically water, so it's 1 gram per milliliter. That converts grams into milliliters. And then there's 1,000 milliliters per 1 liter, and that converts milliliters into liters. And so 1 million divided by 1,000 gives us 1,000 liters. And that's 0.63 moles over 1,000 liters. And so that ratio then becomes 6.3 times 10 to the minus 4th moles per liter, or 6.3 times 10 to the minus 4th molar solution. And that's it for the remaining material from the Wednesday, September 2nd class.